You're a scientist in the 19th century. You've got two elements that no one has ever reacted together before. But how are you going to be able to predict what the result is? If only you had a tool to help you. Enter the periodic table. I'm Mr. Lee. Welcome to Chemistry Revision Stories. In this episode, we're going to be looking at the key developments of the periodic table. But before we do that, it's time to check the homework questions from last episode. The first question was, what two particles are found in the nucleus of the atom? And it is, of course, the positive protons and the neutral neutrons. Our second question was, how many times smaller is the size of the nucleus compared to the size of the atom? And the answer for that one is 10,000 times smaller. Absolutely tiny. And our final question was, how did Bohr change the model of the atom? And he realised that the electrons are found at fixed energy levels around the nucleus. So really well done if you've got those three questions correct. Today's story starts on a dark winter's night. There's a snowstorm raging outside the window, and Dmitri Mendeleev has been working solidly for 3 days to try and organise the known elements. As he succumbs at last to exhaustion, he finally drifts off to sleep. And in his dreams, he sees all of the 56 known elements arranged in a grand periodic table. But how did he get there? What did he do that was so special in arranging the elements? He wasn't the only scientist working on this problem at the time. One of the key things is that scientists had arranged the elements in order of atomic weight. That was quite common, from the lightest element to the heaviest element. Other scientists realised that you could group elements together, those with similar properties being in the same group. But often these versions, the trends and the patterns, broke down after a while. So what did Mendeleev do so differently? Well, he combined those two methods together. He put the elements in order of atomic weight, but what he did was focus on putting them in groups with similar properties. And that meant he realised something very simple but quite profound. He needed to leave gaps in between his elements. And therefore, he realised that those elements hadn't yet been discovered. So how do we know that Mendeleev's way of organising the periodic table was the best way? Well, just like a magician making predictions about what card you are going to pick, he made predictions about the properties of those missing elements. For example, he predicted what their atomic weight would be. He predicted what their melting point would be. He predicted their density. He predicted what types of reactions they would do. And lo and behold, in the years that followed, sometimes even after his death, new elements were discovered, and they so closely fitted his predictions that we know his way of organising the periodic table was the correct way. So how closely does the modern periodic table, the one that we use in every science classroom around the world, how closely does that resemble Mendeleev's periodic table? It's pretty darn close. However, one of the key things is there's now a lot more elements on the periodic table. We're up to element 118, oganesson. And not only have we filled in Mendeleev's gaps, but we've created whole new rows of elements that he couldn't have even known about. One such example is the noble gases, a whole group on the end of the periodic table that wasn't in his original version. Another key difference is the way we order the elements going along a period. When Mendeleev was making his table, the discovery of protons and neutrons and electrons hadn't yet been made. So now we understand that as we go along each place on the periodic table, we are adding one proton to each element. And so we order them by what we call now the atomic number. And with the discovery of the electrons, it gives us a much deeper understanding of why elements in a group have similar properties. The electron configurations tell us all about how our elements are going to react. For example, group 1 all have one electron in their outer shell, and when they undergo their reactions, they all lose that one electron, hence why they react in similar ways. However, there's still some elements that can be a little bit tricky to place. So it's time for the element of our episode, which this week is hydrogen. We've mentioned oganesson, the heaviest element on the periodic table with the most number of protons. Hydrogen is the lightest element on the periodic table with just a single proton and no neutrons in its simplest form and just the one electron. So why is hydrogen tricky to place? Well, based on what we've just said, if hydrogen has one electron in the outer shell, then it belongs in group 1. But the chemical properties of hydrogen much more closely matches the properties of non-metals. So hydrogen itself is a non-metal, whereas the rest of group 1 are metals. So let's think about what happens when hydrogen reacts. Well, it very much depends on what reaction we're talking about. In some cases, hydrogen can lose that one electron, just like in group 1, to form a H+ ion. And this is what happens in acidic solutions. But let's think about how many electrons can go in the very first energy level around the nucleus. That can contain a maximum of 2. Therefore, it only needs to gain 1 electron in order to have a full outer shell. And that much more closely matches what happens with group 7 elements. So even with Mendeleev's organisation of the periodic table, even with all we know today about how the atom is structured, one of the fascinating things about chemistry is it can still throw up interesting exceptions to the rule, and they're really exciting for scientists to investigate. Let's sum up the key discoveries that Mendeleev made. Back in 1869, he came up with his version of the periodic table, which is what the modern periodic table is based on. He ordered them by atomic weight going along a period. He grouped them into groups so that the elements had similar properties, for example, their chemical reactions. The crucial thing he did was leave gaps for those undiscovered elements. But more than that, he made the predictions about those elements, so when they were discovered, scientists found out that the elements really closely matched his prediction, which is why his version of the periodic table was accepted, and years and years later, an element itself is named after him, called Mendeleevium. That brings us near to the end of today's episode, but before we go, I have got 3 more homework questions for next time. Question number 1, how did Mendeleev order the elements going along a period in his table? Question number 2, how is the modern periodic table ordered going along the period? And finally, what do elements in a group have in common? To find out those answers, tune in for the next episode. Thank you very much for listening. See you next time.